It's like I don't care about nothing, man. Yeah. Oh,
So this video is all about rotation. So by the end of this video, you will be successful if you know how to do the different types of rotations when it's at the origin. And by the end of the video, you should also know how to find it if it's not at the origin. Okay, so we're going to start the notes. So the figure is rotated about a fixed point. So it rotates around a point. A rotation is a blank transformation. Well, it moves, but the size, shape, and angles don't change. So because of that, you're going to go, golly gee, that's a rigid motion. So a rigid motion, again, the size does not change. Now, when we do a rotation, you can either go clockwise or counterclockwise. Now, if they don't tell us and it's not said, we assume counterclockwise. And the reason for that is because that's the way that quadrants go in a graph. So I will write that quadrants go in a graph. And if I were to draw an example, if you're not sure what I mean by quadrants, if I were to draw an X and a Y axis, this would be quadrant 1, this would be 2, 3, and 4. So you'll notice that I wrote them in Roman numerals. Whenever you're dealing with the quadrants, you're supposed to write it in Roman numerals. So these are the different algebraic descriptors. So an algebraic descriptor is how it changes. So if it goes 90 degrees clockwise, xy will flip and what used to be the x value will change. I want you to notice that 90 degrees clockwise is the same thing as 270 degrees counterclockwise. And 270 degrees clockwise, where we flip it and change what used to be the y value, would be the same as 90 degrees counterclockwise. So if you remember either the 270 degrees counterclockwise and 90 degrees counterclockwise, you would be able to figure out the other two by just knowing it was the opposite. And if it's 180, it doesn't matter if you go left or right if it's 180 degrees, because it will end up going 2 quadrants over. So for example, if I looked at this one, if it's going 90 degrees, let's say clockwise, this picture, if it's going around the origin, would end up here. So that would be 90 degrees, 180, 270. So what if it went 360? Ooh. I think what happens is it would end up going on top of itself, because like 360 degrees reminds me of a circle. So I think that's what happens. So that is correct. It would end up right on top of itself. So what these rotations do is they end up going in a circle. So if I went and drew the lines and I kept doing, or just a bunch of points going through, it would end up making a circle. Very good, student. So the first example that we're actually doing, it says rotate the triangle 90 degrees clockwise about the origin. Now the origin is at 0, 0. So it's where the x and y axis meet. If we go 90 degrees clockwise, what do? Hey, teach. I'm pretty sure the xy would flip, and then whatever used to be the x value would change. I think I'm right on this one. You are right again, student. You now, if I'm going 90 degrees clockwise, xy, like you said, would turn into the y opposite of x. So they flip, and whatever used to be your x value would change. So in this case, if I did a prime, if I did this, I would flip them, and whatever used to be my x value would change. So since it used to be a positive 2, now it's negative 2. B prime, we do the same rule. We flip it, and whatever used to be our x value changes. And for C prime, again, same thing. We would have 2, negative 1. So before I even go to plot it, I do know that if I went 9 degrees clockwise, all these should have went in this quadrant since it was rotated about the origin. So let's see if that happened. A prime was at 3, negative 2. So that is going to be A prime. B prime is at 1, negative 3, 1, 2, 3. This is B prime. And C prime is to the right 2, down 1. And I'm going to connect the dots and going to say, whoa, golly gee willikers. It's the same size, same shape. It must be a rigid motion.
Right.
Okay, so the next one is number 2. It says rotate the triangle 180 degrees about the origin. So again, the origin is at 0, 0. And if it's at the origin and I'm rotating 180, it needs to go 2 quadrants. So this should end up, so this would be 90, 180. So my points should end up here. So the rule for 180 is what? All right, yo, check it. So I know I'm just learning this, but I'm pretty sure when it's 180 degrees, we don't have to flip them or anything. It's just the x and the y value change. So if it was like positive, it would turn negative. If it was like negative, it would turn positive. That student needs a gold star because he is correct again. What we do is we change the sign. So if it used to be positive, we turn it negative. If it was negative, it would turn positive. So in this case, A prime would turn into negative 2, negative 3. B prime would be at negative 3, negative 1. And C prime would be at negative 1, negative 2. So now we can go ahead and plot that. So A prime is to the left 2, down 3, 1, 2, 3. A prime. B prime is to the left 3, down 1. That would be B prime. And C prime is to the left 1, down 2. And I'm going to say to myself, after I've connected the dots, well, golly, it looks the same. It looks like it's the same size, same shape, just in a different spot. So it must be a rigid motion. Number 4 says rotate the rectangle 90 degrees counterclockwise about point A. So when I do this, instead of it being at the origin, we are rotating around point A. Point A, they told us, is at negative 2, negative 3. So we are no longer going around the origin, we are rotating about point A. So in this case, that would mean A is not going to move, and this picture is just going to turn this way. So there are 3 steps when it's not at the origin. Step 1 is to subtract the point of rotation. So if you don't know what the point of rotation is, it's whatever it says after the word about. So after it says about, it's telling you where your point of rotation is. Now, the second step is to do the reflection. So in this case, they wanted us to go 90 degrees counterclockwise. So if I wrote the algebraic descriptor for that, xy would then turn into the opposite of y, x. So you flip them, and whatever your y value used to be, it changes. So that would be what we do for number 2. Step 3 would be to add the point back in. So now let's go ahead and do that. So m was at -5, -3. Step 1 wants me to subtract the point of rotation. So if I'm going to do that, I am going to be subtracting a -2 for the x value, and I'm going to be subtracting a -3 for the y value. In this case, minus and negative, the signs have to change to positive. So -5 plus 2 is -3. And -3 plus 3 is 0. So what we just did was step 1. Now we're going to do step 2. Step 2 said to do the reflection. So our point that we just found was -3, 0. We're going to now do this rule here. So since y is 0, we don't have to change the sign. So sorry about that, the dogs saw somebody coming up to the house, so they went a little nuts. But now, when we do this, the y value is 0, so we don't have to change the sign, because 0 we do not have to change. So we are going to have 0, -3 for step 2. Step 3 wants us to add the point back in. So what we're going to do is we're going to add a -2, and I'm going to add a -3. When I do that, 0 plus -2 is -2. -3 minus 3 is -6. So in this case, my m prime value will be at -2, -6. So if I go to graph this, I would go to the left 2, down 6. This will be m prime. Now I'm going to want you to be able to have a chance to practice this. So when I'm going to only do A as well, and the reason I'm going to just do A real quick is because A is already on the point it's rotating about. So that means A prime is going to still be in the same exact spot. So this one will not change. So this point stays the same, and because I'm lazy, I'm just going to put a prime next to that. So the other two can be practice for you to do these steps. So now we are on page 5, number 10. It says, consider the following graph. Rotate 3, 4, counterclockwise 90 degrees about the point 5, 7. So this is where we're going to still use those 3 rules that we did on the problem before. This one, I'm just going to go ahead and call 3, 4 point A. I'm just doing this so that it makes it easier for me to visualize. So when I make my new point, I can see which one is the pre-image and which one's the image. Now, if I'm going counterclockwise 90 degrees, I know when I do an algebraic descriptor, I start with the x, y, but what is going to be the rest of it? So teach. I'm pretty sure x, y would flip, and whatever the y value used to be, it would change.
That is correct.
Wow, that student must be butter because he is on a roll. So what we're going to do is, like he said, flip it, and what used to be the y value is going to change. So when we do this, that's the rule we're going to do for what we called step 2 last time. So the first step, we have the point 3 and 4. Our first step said that we were going to subtract the point of rotation. So we're going to subtract 5, subtract 7. So 3 minus 5, negative 2. 4 minus 7 is negative 3. So this would have been the step 1, in case you like writing what steps you're doing. Step 2 is to do the rotation. So what used to be my y value was negative 3, so now it's going to be positive 3 and negative 2 there. So that would be the rotation to the point. And now the last step to find our answer is to add it back in. So I'm going to add 5 and add 7. When I do this, I get 8, comma, and then negative 2 plus 7 is 5. So A prime is going to be at 8, 5. So to the right 8, up 5. 1, 2, 3, 4, 5. So that would be where A prime is located. So the last one I'm going to show you in this video is number 11 on page 5. It wants us to use the preimage quadrilateral EFGH and rotate it about point A 90 degrees clockwise. Explain how you rotated the figure. Draw and label the rotated image as EFGH prime on the grid below. So typically, like if we looked at the one above it, typically we already have an X and a Y axis. Now, in this one, you notice we don't have that. So technically, we don't know the values. So the best way that I know how to do this is to go ahead and make your X and Y axis. So this would be my X axis, this would be my Y. By doing this and making it so that they meet at A, I am making A the origin. So by doing that, all I have to do is rotate it 90 degrees clockwise. So when I do this, the rule or algebraic descriptor is going to be what? So yo, teach, I don't want to be the only one answering, but I'm pretty sure with this one, we're going to flip them, and then what used to be the X value would change. I'm going to have to make sure to get some candy or something for that student because they are on top of it. Now, like he said, we're going to flip it, and whatever used to be the X value is going to change. So, I'm only going to do one of them with you, and then the rest would be practice for you. So, let's say if I did F. F is located to the right 2, up 8. Based on the X and Y axis that I created. Now, if I use arrow notation to figure out where it's going to go, F prime is going to use this rule. So I'm going to flip them, and whatever used to be my X value is going to change. So I would have 8, negative 2 now. So I would go to the right 8, down 2 for F prime. So all these points, since it's going 90 degrees clockwise, should end up in this quadrant. So the rest, again, are for you to try. So that's the end of this video. Again, this was practice where you had rotations, where it was at the origin and when it's not at the origin. So hopefully you have a better understanding of it. The rest of the problems that we did not do are extra practice for you. So I hope you found that informative, and I hope you enjoy.